Hey everyone, today we want to cover Karnaugh maps and how to simplify Boolean expressions. So when we look at some Boolean expressions, some are very simple. If we look at the first one, for example, we can see where it says P equals A or B. However, when we get to the last one, we can see that it can be a lot more complicated and eye-watering. Let's try and make that a lot simpler, and let's try and break down how to use Karnaugh maps to simplify equations so that we can possibly reduce the amount of circuit pieces required or components required for any logic circuit. So the idea of a Karnaugh map, as we said, is to simplify a Boolean expression. This particular one here, as you can see, there are two components, and the expression is P equals A or A and B. We have our truth table here, but we want to see if we can reduce the components here, and can we have less components to do exactly the same thing. So in this example, I have a basic Karnaugh map with just two inputs, and what we can see from here is that we have two variables. So A goes along the horizontal axis in this case, and B goes in the vertical. These could have been either way around, and the expression will simplify if it does simplify in the same way. So it doesn't matter which way around the variables are. And what we can see here is when we plot our equation, so if we look at the first part of our equation, which is just A, that means that we need to fill in everything where A is true. So in this case, we've got 1 and 2. And the second part of the equation, after the or, because we separate our equations where the ors are, let's make that pen a little thinner, is where we have A and B. So now we need to look for the table where A and B are both true. So if we look here where it says B is 1 and A is 1, where the intersection happens here, this is where our 1 needs to be filled in, but we already have a 1. So the next thing we do is we group them together. So we put a rectangle around the ones here. So we've grouped, and you have to group in groups of 2, 4, 8, or 16. Once we've grouped any group that we group, we then have to see which variables change throughout the grouping. So if we look at this one, and we look at the A variable here, we can see that the A variable doesn't change. So within this group here, A is always equal to 1, okay? However, if we look at the B, so within this grouping here, we can see that, well, the B, whether it's true or false, well, it changes from 0 to 1. So because B changes, that means that this part of the equation in this particular box here, in this grouping, is equal to just A. And since there's only one box in our Karnaugh map, that means that we can really simplify our equation just to A. So A or A and B simplifies to just P equals A. Right, now we have another one. So this is another logic circuit, and let's see if we can simplify this a little bit more. So this particular equation is P equals not A and B or A and B. And as always, it might be better for us to group parts of our equation in brackets so it's easier for us to read, even though my brackets are not the best shape you've ever seen. So let's start by plotting not A and B. And so that would go into this particular cell here, where we can see from this column, this is not A, and this is B, where B is true. And the second part of our equation is A and B. And if we look at that, that would go into this particular intersection here, where both A and B are true. And so then what we can do is we can group the two ones that we have together, and then we just analyze each variable within the grouping and see if they change or not. And in this instance, we can see that A is changing from 0 to 1, 0, 1, but B stays constant at 1. That does mean then that this particular equation simplifies to just B. Right, let's have a little more context before we go a little bit deeper. So far what we've done is we've looked at Karnaugh maps with just two inputs, two variables. Okay, in the particular table you can see here, there's a possibility of 4 variables. And now Karnaugh maps work great for anything up to about 4 variables. Anything more than that, it becomes a bit more difficult. However, in the exam, your exam board will never give you, will probably never give you any questions with more than 4 variables. So things that we need to understand is, we did mention this earlier, is that we group items in groups of 2, 4, 8, or 16. With a larger Karnaugh map, you'll notice what's known as grey code sequencing. So if we notice here, you wouldn't have seen it on the smaller Karnaugh map, but we count up in binary. So we go 0, 1, but at this point, rather than going to 2, we go to 1, 1, so we go to 3, and then we have 2 here. And the reason we do that is because with grey code sequencing, what we're trying to do is make sure that only one digit changes at once. And that then supports the next point, which is that in our Karnaugh map, if we have a group of ones, but they're on either side, we can do what's known as a wraparound. And if we look at the variable here, the 2 variables here, 0, 0 and 1, 0. So if we look at that in terms of binary numbers, only one digit has changed, just the 1 has changed here from the 0. So that also supports the fact that we can wrap around and group 2 ones on either edge. Okay. The next thing we have to know is that we have got to group the largest first. So you should try to cover all the ones in groups of 2 or more that have not yet been covered. So in this instance, the largest grouping would be this one here with a group of 8. And then the second largest grouping would be this one here, which I've covered in blue. And importantly, what we want to do is not leave any ones out that have not been covered. Obviously though, if it's a group of 3, we're not going to touch that. It has to be groups of 2, 4, 8, or 6. Oh, on my slide here, I can see I've made a mistake. Sorry guys, that should be 8 or 16. Right, so let's take an example now where we have 3 inputs. So I've got a nice long equation here, not A and not B and C, or not A and B and not C, or A and not B and C, or A and B. And that's quite a mouthful, right? So can we take that and can we make that more simplified where we're going to use less components? So here what I've done is I've broken down an equation into 4 parts. So I think you saw that on the previous slide as well. So I've broken it down into 4 bullet points, and then I'm going to start plotting them one by one. So the first part is not A and not B and C. So just like before, you can see that I've plotted A and B along the horizontal line, and the C is plotted along the vertical line. So we need to look at where it says not A and not B. So we can see in this first column here, this represents our not A and not B together. And we also want to find where C is true. So that intersection would only happen in this cell here. So we put a 1 in that cell. Right, then we look at the next part. The next part says not A and B and not C. So not A would be here, and B would be this column here actually. So not A and B and not C would be in this cell here. So we add a 1 there. The next part of the equation says A and not B and C. So A would be here and not B, and C would be in this cell here. And the last part of the equation was A and B. So in this case here, A and B are both true in this column amongst both rows. So we would add 2 1s there. Okay, so now we want to group some of these together. And in this case, it seems like the biggest grouping we're going to have are only groups of 2. So it doesn't really matter too much where we start. So let's start with this one here. And the next group of 2 we can see is in the bottom right. And then lastly, we don't want to leave any one that could be part of a group of 2 or 4 or 6, sorry, not 6, 8 or 16 as part of a group. So what we do is we use the wraparound method, and we wrap around in the green box, as you can see here. So let's start by analyzing our green box. Like we said before, we want to look at what variables there are here. And we can see that A is changing. So if we look here, 0 there and 1 there. So the A variable is changing. So that's a negative. Then if we look at B, B is constantly 1 in both these columns. And C, even though it's not true, it's constant as not C. So that first part of the equation would be Q equals B and not C. Now let's look at the second grouping, which was the blue grouping. And we can see that here, A stays constant. It's 1 in both columns. B is changing between 1 and 0. And C is constant at 1, so it's true. So this part of the equation gets added to our previous one, and then we're left with our last grouping, our wraparound, which we can see that A is changing from 0 to 1. We can see that B stays false and C is true. So the last part of our equation would look like this. So our final equation is B and not C, or A and C, or not B and C. And compared to our first equation that we looked at, that's a lot smaller. So that is a lot more simplified. Let's walk through another. So in this example, again, we have 3 inputs. So we'll plot the first part again. Here we can see the first part is not C and B. So not C and B would be in 2 columns here. The next part is A and B, which we've added here. And the last part is just C. So that means we add all of the bottom row there. Okay, so let's try and put our groupings together. The first one we're going to group is this one here, a group of 4 in blue. And it looks like our second grouping includes all the rest of the ones in a group of 4 in one line. So now if we look at our variables from the first group, we can see that A is changing from 0 to 1. We can see that B stays constant as 1. And C changes from 0 to 1. So our only constant here is B. So that means that the first part of our equation is Q equals B. And then when we look at our second grouping, we can see here that A is changing from 0 to 1 across all 4 columns. We can see the B is changing in the same way, and so we're left with our constant of C. So that means that this equation simplifies to Q equals B or C. Right, compared to our original equation, again, that looks a bit smaller, so we have simplified it. It's important to note that we can't always simplify every logic circuit. Right, now let's look at an example of 4 inputs. So our equation here is Q equals not C and B, or A and B, or C and D. I've broken that up into 3 points. Okay, so as you can see in this example here, we've plotted A and B along our horizontal axis and C and D along our vertical axis. Why not pause it here and try to plot this equation in the graph and unpause when you're ready. Okay, hopefully you've given that a go. Let's try and plot this onto our Karnaugh map. Okay, so now if we try to group together our ones, so it looks like these might all be groups of 1. Groups of 4. The first one I can see is here we have a grouping of column A and B in this one. Then I can see this column here, and then we would have another column, another grouping, sorry, with groups of ones that crisscross as well, or that overlap, should I say. So if we look at the variables now on each one, so the first grouping, the blue one, we can see that A and B here remains constantly true, and C and D are changing from 0 to 1, so they're both false. So that makes our first part of our equation is A and B. The second part of our equation, if we look at our red grouping here, we can see that A and B are constantly changing across the 4 columns, but C and D remain constant here as both true. So that means that our second part of our equation is or C and D. And then our last grouping here, we can see that A is changing from 0 to 1, B remains the same, it's constantly true, C remains the same as not C, so we can see here they're both on zeros, and D is false. Oh no, sorry, it's not false, it's because it's changing from 0 to 1. So that makes the last part of our equation or not C and B. Right, so that's the last one that we're going to look at done. As always, I've got some worksheets for you, so please check out the link on the video. Please do them to practice, and I'll see you in the next video.